So this paper, although it only has one side of notes, the reason there's only one side is because there's really not a lot to talk about. Like, I'm going to show it to you one time, and then we're going to practice different levels of difficulty. The first thing we're going to talk about is the most important thing. And I know I probably say that a lot, but like legit, the triangle sum theorem is something you should never forget because it comes up a lot. Okay, the exterior angle theorem will only come up this week. It's not used a lot, and I'm going to show you why. It is in the standards, so I have to check the box. Yep, I showed that to them. We talked about it. We practiced it. If it's something you forget, it's okay, because there's actually a way to work around it where you don't even remember the theorem. So let me show you. So the first thing, the triangle sum theorem is the sum, says the sum of the interior angles of a triangle is 180 degrees every single time, every day, all day. Doesn't matter how goofy looking the triangle is. It can be one of those gigantic, like, obtuse triangles. It can be some, like, little weird triangle. It does not matter, okay? All three angles add up to exactly 180. Never 179, never 180.1. It is exactly 180 on the dot, okay? So put that in your tool bank of every time I see a triangle with angles, I know they all add to what? 180. Stay with me, Michaela and Landon. So we have a picture of a triangle here. We have three angle vertices named A, B, and C. So our equation, much like what we've been doing, where we need like multiple choice, or not need, but where we say multiple choice options for setting it up, it's very similar to like part, whole, but we have how many parts per triangle? We have three. So you've got angle A plus angle B plus angle C equals 180. So that would be your equation. And we'll put EQ ... for equation. Let's jump down to number 1. Jump down to question 1. That is the shallow end of the pool. So I'm not gonna guide you too much. I want to see if you can just jump in there and figure it out. It does have a question mark in one of the angles. Probably do it in your head, but you can check it in your calculator. You're looking for the measure of the missing angle in number 1. What'd you get? 80 degrees. There's 2 ways to set this up. I want you to look at both of the ways and decide which one you like, okay? One way is kind of like a order of procedures, like the 3 angles add to 180. Okay, so I see question mark plus 60 plus 40 equals 180. And then you could solve it from that. So question mark, add the 60 and 40, and then subtract the 100, and you get 80. If that's the way that you want to go, that's fine. It does require more writing, but it works. Let me show you a second technique that also works, requires less writing, and it will actually help you down the road when we get to the stuff that requires more steps. It's called the subtraction method. We've talked about this. The subtraction method is you take the total, like you know the total. What's the total? Stay with me. What's the total? 180. And you subtract off what you already see and know, and that's going to leave you with what's left. So I know in my head the total's 180. I'm going to subtract 180 in my calculator or in my head. I'm going to subtract 60 off of 180. What's that leave me with? 120. And then I'm going to take 40 off of 120. Well, what does that leave me with? 80. The subtraction method works. It's a more intuitive method because it lets you take what the total was and bring it down to only what you need. So I would encourage you to try both methods. All right, try number 2. Same exact principle, it's just a more challenging picture. Not that they can really, yeah, it's still going to add to 180. It does not really get more challenging, it's just the equations just get longer. Now you could use the subtraction method here. You could take your total, subtract off the angles you absolutely know, and then you would be left with an angle that you need to find. So if the total is 180, what can I subtract off? All right, if I take 180, go to my calculator, 180 minus 60, that leaves me with 120. What else can I subtract off? This little square means 90, so I can go back to my calculator. I have 120 in my calculator. Let me actually pull mine up and I'll show you. Alright, so we did 180 minus the 60. Then we said we can subtract off that 90, and that leaves me with 30. You have to know what you're working with here. I took the 90 off. So this angle right here has to measure what? 30. Here's your equation. 5x has to equal what? 30. So set it up. 5x has to equal 30. So x has to be 6. Look how easy that was. The alternative method, which is still easy, it's just going to be more writing, is to say 60 plus 90 plus 5x has to equal 180. And then you would have to solve that. So look at the subtraction method technique versus writing the whole thing out. I would only suggest writing the whole thing out if you're still a little rusty on this. Once you start getting it really good, I would entertain the subtraction method. The subtraction method, you only subtract off the stuff you absolutely know. So I did 180 minus 60 minus 90, and that left me with this corner. I labeled it, and then I knew my equation. Okay. All right, go to number 3. Number 3 has 3 angles. How many of them do I already know? I only know one of them. But I can still use the subtraction method here. What do I know the total has to be? 180. What do I already know in the picture? So I can do 180 minus 72, which would leave me with 108. Now, 108 is not one of these angles, because how many are left? 2. And I don't know either one of them. So 108 would be between both of these, which means there's your equation. You're going to add those 2 expressions up to equal 108. You see how that works? So x plus 42 plus 74 plus x has to equal 108. And that's a much smaller equation than if you had thrown in the 72 in there and the 180. And you would solve that. Did you see how I got that? A little bit? I'll explain it one more time. So they have to all three add to 180. So I did 180 minus the angle I know, which leaves me with 108. And I know there's two angles left. I can't subtract anything else off. But I know they have to add to 108. So you would solve that down. Yeah, it does say find the measure of the missing angles, but it should probably just say solve for x or the missing angle. Yeah, keep going. Yeah. So x, and you'd have 2x plus 116. Is that right? So combine your like terms. You got 2x's plus 116. And then 108 minus 116 equals what? Negative 8. And x would be, now, can x be negative? The answer is it depends. You have to go back to the picture, plug the negative in, and just make sure the angle's not negative. So if I plug -4 in right here, does that give me a negative angle? No, I still end up with a positive angle. Then come over here and plug it in. I still have a positive angle. So x can be negative as long as you go back to the picture and make sure it does not make a negative angle. For right now, you can't have negative angles. If you go to the pre-cal class, you're going to learn there actually are negative angles, but for now we're only dealing with positive. All right, so that's the triangle sum theorem. You can probably see the level of difficulty as it increased, but the concept is the same every time. Then 3 angles add to 180. That's it. Okay. Next is the exterior angle theorem. I tend to call it the bougie angle because I feel like it's a little extra. It's fluff. It's not necessary to know the theorem itself. So you'll hear me call it the bougie angle. I don't know how to spell bougie though. B-O-U-J-I-E? G-B-O. That looks like boogie though. I don't know. All right, we're making it up. If I do a G, it's gonna make me think boogie. Bougie. I have no clue. Anyways, you're going to hear me call it that's the bougie angle. And it's because it's extra. It's the angle on the outside of the triangle. So it's like, okay, good grief. We're dealing with the triangle, and you're going to go extra on the outside. Look right here at this picture. Do you notice 1 and 4? Now, you're used to angles 2, 3, 4 form that triangle. But 1 is out here on the outside. It's out here. Right? You see that? What do you notice about 1 and 4? You should think of a vocab word we learned on Friday. No, Thursday. What do 1 and 4 do? How are they arranged, positioned? Look at Thursday's worksheet. Might be page 14, maybe. Starting to hear it. What did you say? Try again. You're so close. What's the other one? There it is. Supplementary. They form a linear pair. Do you notice how, like, if you think of puzzle pieces together, do you notice that angle 1 and angle 4 form this straight line right here? You see that? Y'all with me? That means they do what? There's a math equation behind that. What do they do? She just said it when she said supplementary. Linear pairs are which one? Which math equation? Alright, so there's a little bit of studying that y'all need to do before the quiz tomorrow. Linear pair, straight line. The angles do what? Look at your notes.
180.
Yes, they add to equal 180. Very good. So this angle 1 plus angle 4 adds to equal 180. You with me? Okay. What do you notice about angles? Follow what I say. 2, 3, and 4. Ignore this. Angles 2, 3, 4. What shape are they? They form a triangle. What do you know about the angles of a triangle? They add to equal 180. We just practiced it. Y'all with me? Michaela, Landon, y'all gotta wake up, please. They add to equal 180. So 1 and 4 add to 180. 2, 3, 4 add to 180. What do they both have in common? They both add up to equal 180. And what angle do they have in common? What angle did I repeat in both of them? Angle, did you say it? 4. Do you notice how angle 4 was in both? So watch this. Angle 1 plus angle 4 equals 180, right? And angle 2 plus angle 3 plus angle 4 equals 180. Because that's the triangle. They both have what in common? They have angle 4 in common. Well, I'm just going to subtract the 4 off. If I take the 4 away, here and here, now they both equal 180, and I can set them equal to each other because of substitution. Like if this equals 180 and this equals 180, then they both can equal each other because of substitution. So watch. Angle 1 equals angle 2 plus angle 3. And that is the exterior angle theorem, which is bougie because it is a little extra. It's a measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. All right, look at the picture. So angle 2 plus angle 3 adds to equal angle 1. Angle 2 plus angle 3 adds to equal angle 1 out here. Bougie. Extra. You really don't even need this theorem. You could just say, well, these have to add to 180. So 2, 3, 4 have to add to 180, and you could use substitution. But someone said, now let's create a theorem for it. All right, so let's come down here and practice. You do have to make sure it's the two angles that are not adjacent. Notice angle 4, which is touching the exterior angle, does not get used at all. So make sure it's the angles that are not touching that exterior angle. Come down here to number 4. All right, let's look at it. Here is the exterior angle. It's like someone drew a triangle and then they slipped up and just kept drawing, right? So here's the exterior angle. Go to the triangle and find the two angles that are not touching it. That would be this corner here and then this corner here, right? So set it up. The angle on the outside, so this is the, on the right, bougie. the bougie angle. The bougie angle equals the sum of the two interior angles. So 87 equals question mark plus 45. So what's the question mark angle going to be? What'd you get? 42. When you subtract 45, you get 42. All right, let's try number 5. Find the bougie angle on the outside. Which one is it? 107. So I'm going to draw an arc and I'm going to label it bougie. The bougie angle equals the sum of the two interior angles. So that would be this one and this one. So let's set it up. The sum of the two interior angles. So 107 equals 49 plus 9x minus 5. There's your equation. Get 7. All right, number 6 is a more challenging one. And I'll be honest, number 6, you don't even have to do the bougie angle thing. There's another tip you could. I'll show you both. We'll do the bougie one time and then I'll show you the other technique. There's a lot going on in 6, right? There's not just one exterior angle. They've given us several. If you notice that the bougie angle, right, is when the triangle is drawn and then just one side keeps going. So where in this picture is the actual bougie angle, the exterior angle that we've been learning about? The 100. Do you notice how that's where like it looks like the triangle got drawn and they just one side they just kept going? Because up here it looks like two sides kept going, right? So this is the actual angle that we've been learning about. I call it bougie. It's just an extra theorem to learn. There's a vocab word to describe the angle 10x, and it's from Thursday's lesson. Can anyone think of the vocab word? This is good practice for the quiz tomorrow. Can you think of the vocab word from there is an angle that's congruent? Keep going. When two lines cross? Nope. Keep going. Anytime two lines cross, you have vertical angles. And vertical angles are congruent. Where's the vertical angle in here? Think of the double-sided flashlight. So I see 10x over here. That's two straight lines. So then I can write 10x right here. Do you see that? So they've given you info on the outside of the triangle that actually can just come right in because it was two vertical angles. Now I can see that this bougie angle out here is going to equal this 10x angle right here plus this 5x plus 10. So let's set it up. Bougie equals 10x plus 5x plus 10. What'd you get? 6. Good deal. How do you feel? Besides tired. Any questions?